Hello, I'd like to go over the concept of the chi-squared test with you, and in doing so, look at problem number 2 from the homework assignment. So it says a recent study undergraduates looked at gender differences in dating trends, 187 women, my example says, and 107 men. So it only gives you the number of women who said yes and the number of men who said yes. So if you think about it, to find the number of no's, if you know there's 187 altogether, if you subtract 36 from 187, you'll get the no's. And you can fill in the pieces here that are required for the no's and the gender. Once you know those pieces, in order to get all of these parts here, okay, summarizing the data as far as a percentage goes, you should know how to find a percentage of something. It's a straight percentage, nothing fancy, okay? But to find the chi-squared number, that requires the formulas. So if you want to use the calculator, I provided it over here for you. So what I do is you enter the two parts of the 2 by 2 chi-squared test, which is the 36 and the 8. Enter the 151, which is what I found when I subtracted 36 from 187, and the 99, which I found by subtracting 8 from 107. When I put those four numbers in, the rest of it fills in here. It also calculates the expected value. The expected value, okay, of the first cell is D5, which is the 44, times B7, which is the 187, divided by the grand total, which is 294. So what you're doing is you're taking the combined totals of the first, the woman and the yes, the combined totals, multiplying those together and dividing by the grand total. And that gives you the expected value. And you would do the same for this. So you could do this by hand. It's not a big deal, but I just wanted to show you how I came up with the formulas for my template. The chi-squared is, of course, the formula for chi-squared. It looks fairly complex this way, but I've ended up stretching it the whole distance across here. It wants the number one, and so you see B5 minus F5. So what you're doing is you're taking the given of the sample minus the expected value and squaring it and dividing it by the total, and so on, of that particular. And if you look at the formulas in the text in section 9.1, you'll see that. That'll find you the chi-squared number, find you degrees of freedom. Degrees of freedom is basically number of rows minus 1 times the number of columns minus 1. And then there's the p-value, okay? I've also built a template for a 3 by 2 chi-squared, because you'll see that in a later problem. Same technique as it was for the other. Okay, so that's how you can use the chi-squared test template for many of the problems in this week. Take care.